Well, I saw this integral on YouTube. I have my way of doing it, so I want to share with you. Now, the first step is just to rationalize the denominator, which is 0. This numerator times this, right? X plus x minus 1, 1 minus x. Yeah. And the denominator becomes 2x. Huh? That's easy. Now, then it becomes a 2 integral, 0 to 1, 1 half x, 1 plus x dx minus 1 half integral x, 1 minus x dx. Well, I call this one is I1. I call this one is I2. Can I just do them separately? I1 is equal to 1 half 0 to 1, 1 plus x, x dx. That is this one. I use substitution. I let x be u squared minus 1. And it becomes 1 half. When x equal to 1, when x equal to 0, sorry, u is 1. When x equal to 1, this will be root 2. Okay, this is a u. Dx will be 2u du. This will be u squared minus 1. Okay, so this is equal to 2 cancel out. Comes 1 to square root. U squared du, right? U squared minus 1. So minus 1 plus 1. Right? So it becomes a 1 plus u squared minus 1 du. Yeah, this integral is easy. This one is equal to u 0 to 2 root 2. This integral is equal to 1 half, right? 1 half log u minus 1 u plus 1. Yeah, the absolute value. So this one is equal to root 2 minus 1 and plus 1 half natural log root 2 minus 1 root 2 plus 1 and minus 1 half natural log well, this one you have to take a limit, right? 1 half the limit u goes to 1 u minus 1 u plus 1. Okay, I hold it for a while. Now let's do the I2. I2 is this. I2 is 1/2 integral from 0 to 1. This is just square root 1 minus x dx. I introduce, a substitution, right? I let x be 1 minus v square. Well, just say 1 minus v square, okay? So dx is equal to negative 2v dv. So my integral becomes 1/2 x, when x equal to 0, this is v must be 1. When x equal to 1, v is 0. This is 1 minus v square, and this is v. 1 minus this is v, yes, and then negative 2v dv. So this one is equal to negative v square dv, right? 1 minus v square. Negative, yeah, v square, 2 cancel half. Yeah, now if I switch the order, I change this to plus, right? Then it becomes 1 to 0 to 1. Yeah. Then I change this again, becomes negative again. 0 to 1, v square minus 1, right? If I switch in this order, it becomes negative again. And then minus 1 plus 1 dx, dv. So it becomes negative v from 0 to 1 minus the log v minus 1, v plus 1. Yeah, absolute value from 0 to 1. Yeah. This one is equal to negative 1. Yeah. Negative 1, yeah. This is this is take limit, right? The limit v approaches to 1 from left. Yeah. V minus 1, v plus 1. Plus, the negative change it plus this is log 1, right? Equal to 0, yeah. Then my original integral I is equal to I1 minus I2. I1 is this. I1 is root 2 minus 1 plus 1/2 log root 2 minus 1, root 2 plus 1 minus 1/2 the limit u approaches 1 from the right, log u minus 1, u plus 1, and minus I2. This is I2. So it becomes plus 1 plus the limit v goes to 1, v1, v plus 1. Yeah. So that I have half here, right? Yes, I have half. It's half. Ah, sorry. Okay, there's a half here, okay? There's a half here. A split in is two, yeah. This one's half. And that one cancels with this one, you see? Then it's end up with root 2, 1 cancel out, plus 1/2 natural log root 2 minus 1 plus 1. Yeah, that is the answer for the integral. Excuse me, there's somewhere in the messy writing. I think you can trace back. Yeah, I think this is a little easier than the other methods. Thank you for your watching.